of you may recognize me from here, from Technicelpa. Just introducing this webinar and giving you some useful tips on how this session will work so that you can get the best out of this next hour. On behalf of Technicelpa, we would like to welcome you and thank you for having registered and reserved this short period of time to join us in this event. This webinar will be held in collaboration with Firefly, one of our collective members, and is dedicated to prevention of fires and explosions in the pulp and paper industry. We have the collaboration of Mr. Raul Moreno, engineer and MBA, has been working in Firefly for almost 10 years, developing different solutions for various industries. He is director for Portugal, Spain, and Latin America within Firefly. And also Mr. Metz is a Master of Science and has a background in the industrial and process safety industry. Metz has been working as a risk and safety consultant for 8 years before joining Firefly, helping numerous of industries with different types of fire and safety analysis requirements and procurements. Throughout the session, your microphones and videos will be turned off with only the dialog box chat and also Q&A available on the bottom of the screen, where you can post your questions in writing during the presentation. You should try to write it in English, but if you can't, you may also do it in Portuguese, and we'll try to help the translation. At the end of the presentation, will be reserved time to Q&A, where Mr. Raul and Mr. Matz will seek to answer your questions posted on the chat. In case we have a lot of questions and it's not possible to answer everyone today during the webinar, we'll try to provide the answers by email. Also to inform you that this session will be recorded and will be available at the Technicelpa's YouTube channel to see it again. And also will be sent to you a link so you can see it. After finishing, you will receive a brief questionnaire which asks everyone to answer and send according to the instructions. Your feedback is also very important. So I believe we have not only, but most of the participants already in the room. And I will give the floor to Mr. Raul to start this webinar. Thank you all for being here.
Hi, thank you. Thank you, Ms. Maria. Thank you for the nice presentation. Welcome, everybody. On behalf of Firefly, and of course, Technicelpa, we welcome you to this webinar with my colleague, Matt Schistrom, and myself. We will be talking for the next 40 to 45 minutes about the solutions that Firefly has developed. And after that, we will have a Q&A session. As Mrs. Faria told you, please write the questions on the Q&A section of the webinar. If you feel comfortable in writing in Portuguese, please do so. Well, let's with that, let's begin. So we start with the little bit of agenda. We will do an overview of Firefly. We will talk about risks in the industry, Firefly solutions, Firefly technology, and Q&A. So if you have questions when at some of the subjects pop-ups and we're talking about it, just put the questions in and then we will look at it. Okay. So Firefly, we are a Swedish company. We're speaking today from our head office here in Stockholm. I hope that everybody, you and your families, are doing fine, in good health in these complicated moments. We have been in Stockholm for the past 4 years. We are a Swedish company, as I said before. We have different approvals from FM and other organisms. We are focusing on clients, on the client process, and by saying that, what we do is we do tailor tailor-made solutions to your process. So we are looking always on the industrial side of things. We have proven reliability, and also we are a global company, meaning that we have a global reach, not only on selling systems, but also in supporting. As Mrs. Faria was telling, I'm responsible for the part of Portugal, Spain, and Latin America. But as myself, there are other colleagues that are in charge of different regions of the world, Europe, Asia, North America, and then also my colleague Matt Shilsom, he's in charge of solutions for the pulp and paper industry. So this is one of the industries that Firefly is servicing as a Swedish company. We started 4 years ago, focusing on wood panel, woodworking solutions mainly. But as the years have gone by, we have specialized in different solutions, in not only in tissue or wood-related products, but also in fields so different, like could be recycling, could be power generation, could be food, tobacco. So in every process there is a risk of having a fire, not because it is a failure of the process itself, but because the process itself has materials that could cause this fire. That is where Firefly we have been focusing on special solutions. We have, let's say, two Firefly protection systems family, and the first one is based on prevention systems. And on prevention systems, we have two main solutions. One that it's a spark and hot particle detection system, and a second one that we call MGD, or electronic nose. This name may sound a bit strange, but we call it electronic nose because it actually, the detectors that we use here actually work like our nose, meaning that, for example, when you're at your home and some of your neighbors are doing a barbecue, you don't see the barbecue itself, but you smell it, and your brain together with your nose identify that that's a barbecue. So that's why we call it electronic nose, because this detector is able to detect a fire in the first stages, where only the gas detection, only the gas particles are being produced and the reactions are being produced at this level. So in this part of the systems, we are doing detection and extinguishing of ignition sources before the fire or the explosion has occurred. And then we have a second family of big families that we call protective systems. In these systems, we have the quick suppression system, which is basically what we're doing is a quick detection of the flames. And when I'm talking about quick detection, our detectors works around about 300 milliseconds. I will talk about that later on. But then the whole idea is to detect and extinguish or suppress the fire in less than 5 seconds. Nevertheless, that we have these two families, normally a Firefly solution often combines both technologies, preventive and protective. This is for an optimal safety solution. Now going into our today's main concern, fire risk. Here we have some examples of fires that have happened in the industry, different industries in the last couple of years and months. On all of them here, you could see in this case, we're talking about conveyors. Normally, a normal failure of a conveyor, a normal problem is caused by friction and overheating of the bearings. In this case, in Sweden, the loss was equal to 20 days of productions, and then they could only recover after 7 months of the incident. This one in Denmark, the firefighting lasts for 12 days. And then this one in the US, it was a conveyor that was carrying wood chips. And then it was, the fire, unfortunately, was not only on the conveyors, but also in the plant silos. And of course, normally when you have a fire in this type of machinery, the consequences spread to other sides of the factory. Other examples talking about pulp and paper throughout these last 2 years. Well, we know the tragedy in Marshall Paper in New Jersey, some Rogers Mill in Domtar, closer to Portugal, Saica Mill. They have also a fire there. And then here in Sweden, we have Monsteros Mill and Hallstahammar Mill. So all these examples, it shows us that unfortunately, the fire and incidents related fire or dust explosions are present in the pulp and paper industry. After this brief introduction, now my colleague Mats will talk about the applications that Firefly has developed for this market. So I give the floor to Mats.
Hello, everyone. Thank you for participating in this webinar. I will talk about different parts of the mills and in what way Firefly can provide protection. We will start at the raw material handling site. Usually, we say that this part is mostly handling wet wood. We usually say that if the moisture content is above 20%, the material is too wet to ignite. But in the past, we have seen fires even in this area. Roel talked about it before. We have seen ignition sources such as frictions from the bearings and the transportation belt in conveyors. And if we talk about the debarking or the chipper, we have seen sparks from metal parts. That's, yeah, of course, usually is not supposed to be within the process, but sometimes there are. I can also talk about the accumulation of dusts within all these types of process parts. If the dust accumulates, of course, it will dry up and the moisture content will decrease. And if there's a spark or some friction heat from a conveyor bearing or a belt where there will be accumulated dust, it's more prone to ignite. And of course, all over the mill we have dust extraction systems, maybe in this part around the chipper and debarker and screener. That's covering the fire risks areas. And I will now talk about different solutions from Firefly to prevent fires and explosions. And I will start with the dust extraction systems. And it's basically a filter protection. You see a picture of it on the right side of the screen. And first of all, we have our detector. Roel will go into the theoretical side afterwards, but yeah, it's basically there to avoid sparks and hot particles, to reach and destroy the filter. And afterwards, we see our power impact extinguishing system with the full cone nozzles. And depending on the diameter of the duct, we place the nozzles in different direction and different places to cover the whole duct. So no sparks or no metal embers could reach the filter. And an option for this application is also a fan temperature monitoring sensor to really have a early detection mode in the fan, because the fan itself can actually work as a ignition source as well. And if you imply this option, you can have an early detection and see what's happening in the fan. Moving on to the conveyor guard, and that's of course protecting different conveyors. And both in a pulp mill and paper mill, there's usually long conveyors. And Roel earlier talked about that we combine both the preventive and the protective systems we have, and conveyor guard is one solution that we do that. So first of all, we see in the chutes here and over here, we use our preventive system, the spark detection system, with the same detectors as we used in the duct extraction system and the same type of nozzles, the full cone nozzle. And depending on why the chute is, of course, we need numerous numbers of nozzles. And if we move on to the actual conveyor itself, this part, we use the preventive system with a flame detector that detects flames instead of metal embers and sparks and hot particles. And we use water mist on the actual conveyor belt. An option here on the conveyor guard is the temperature sensing cable, which we see over here. And it pretty much works the same way as the temperature sensor for the fan. It's an early detection, and we usually place it on the bearings and around the belt, because that's where the friction usually comes from. So we can see an increase of temperature if there's actually problems with the bearings in the belt. And just to show you some movies and pictures of what we're actually talking about. This is an example of our spark detection system, the preventive one. And you see the detector in the middle here. And the guy over here, he lights a match, but then blows it out. Maybe how to press or what? Sorry for the delay. But here it's in slow motion. You see the detector is active, the blue lights, and then the guy on the upper left-hand side, he lights a match. But then he blows it out and drops it on the concrete floor. And then here you see our power impact extinguishing system as well, the full cone nozzle. So what we actually detect is not only light sparks. We actually detect hot particles, which can heat the material itself. So that's what you see in this movie. Going forward in our mills and our risks areas, we go to the pulp mill. After the raw material handling, if we produce pulp, there's a pulp mill, and if you produce market pulp, you dry the pulp and then you bale the pulp. And we've seen fires within these two process areas before. And of course, in a pulp mill, you have dust extraction systems as well. I will not talk about that so much now, as I already told you about it. But talking about the flash dryer, the pulp dryer, depending on how it's built and how big it is, we implement different type of spark detectors. So this is a preventive system with spark detectors and full cone nozzles within the ducts and after the drying stages. What is one important thing to say here as well is that I was talking about accumulation of dusts within conveyors. There's also a possibility of smoldering material within the ducts in a pulp dryer. And yeah, of course, if there's accumulating in smoldering material within a duct that's heated up, the risk for ignition in a fire is, of course, increasing. Moving on to the bale press that we see on the right-hand side, we have not actually water extinguishing, because when we bale the pulp, we don't want to destroy the actual end product. So what we use here instead is inert gas. Sometimes we use steam if it's a possibility for the end customer, but usually we use inert gas and combined with isolation valves, and it's all about not destroying the end product. Yeah, if you can of course produce pulp and paper in the same mill, then it's not market pulp. And if you use a paper mill, the pulp is probably wet when it comes to the paper mill. And here we have dust extraction systems, as we always have, and raw material if it's only a paper mill. I've also stated the boiler and the different types of risk areas within the paper drying process, which I will talk about a little bit more. If we start at the boiler, the fuel is it's very common to be some wood chips, biomass fuel. And if we look at the right-hand side, we see the loading station, where you come with your truck, your train, or whatever to unload the fuel. And in this area, we have delivered flame detectors. So it's if it's detecting flames from the actual fuel. And of course, the dust extraction systems all over the boiler. But if we go further down the stream, after the loading stations, we have fuel feeding sections into the actual boiler. And it's usually some kind of chutes and conveyors. Within a boiler, there's usually not as long conveyors as in the whole mill itself. So sometimes we combine the water mist solution within a conveyor guard with backfire protections within the chutes. So as Raoul told you before, we make the application suitable for each part of the mill and each customer. So it suits the actual location perfect. And if I would say it's not very common, but sometimes there's a mill and a screener in a boiler as well before it's actually the fuel actually ends up within the boiler. And of course, a mill and a screener is a dusty area, so that's a risk as well, where we use our spark detection system. Going further within the actual paper mill, what we see here is a infrared dryer at the end of the paper machine. This is actually well, not maybe the oldest, but we have been delivering protection for infrared dryers for a very long time here at Firefly. Even though it's electrical or gas infrared dryers, we can protect both, because the actual thing we protect is the paper sheet, the paper web. And this is flame detectors with water mist. So the flames look at the actual sheet, and then the water mist puts out the fire. This is just to show you a small short video about what could happen if there's no protection within a paper machine. Just a short video for information. This is where it all started, and it spread to the other parts of the actual paper machine. And this is a picture of the drying part of the section, the drying part of the before the infrared dryer, where we see all the calendars here. And what we delivered in this project was flame detection and water mist protection for the bearings, but because This customer have had fires due to friction on bearings. So we use this type of water mist nozzle and our flame detector. I could also state the point that a new paper machine, its drying section is usually kind of moisty and wet, since these calendars uses steam to dry the paper web. So if it's a new paper machine, this area is probably very moisty and wet to start with. But the fires we have seen here on Firefly is mostly on older paper machines, where the bearings might be, not maintained as good as they have to be, or obsolete or something. So of course we look at the actual fire scenarios as well before we implement our systems. And this is actually on the wet side of the paper machine, a shoe press, the nips. And what we've seen here lately is that the oil leaks from the shoe presses. We've been talking to this with the different customers and insurance companies, and even fire consultants to establish a new implementation of fire protection for the shoe presses. And this is the tending side of the shoe press. This is just an example. Of course, there's open shoe presses and there's closed shoe presses. So we need to adjust where to place the flame detectors and the nozzles to make sure we actually take out the fire. So these ones are sort of spraying from the outside to the inside of the shoe press, and this one is placed within the shoe press to extinguish any fires within. And on the drive side, the lubrication and hydraulic oil, the hoses, comes usually on the drive side. So the quality of the connection on the hoses is of course an imminent risk as well. If there's bad hoses, we need to protect them as well. So this is something that we think is a very good implementation for these kind of shoe presses, because we've seen fires that's not protected at all. These machines haven't been protected before. So this is something we think could help different pulp and paper industries. Last but not least, we have the corrugator, where you produce carton boards and corrugated boards. These boards, of course, are not as soft as paper sheets. The web is not as soft, so maybe the risk is not as big as in a paper machine. But we have seen fires. We have implemented applications before. And what we have been doing then is mainly at the Slater scorer, because that's where we chop up the board, and it gets dusty. And alongside with the heating plates, where the ignition sources comes from, we've seen fires around this area, and enclosed by dust extraction systems, sucking dust from the Slater scorer. But we've seen also risks and accidents within the single phasers and the double backers, mostly around the bearings, where friction, it's the ignition sources is friction, heat from the bearings, and if dust accumulates on the bearings, there's a possibility of fires around the bearings. Thank you so much, and I will now hand over to Raul again to talk about how our systems works. Thank you very much.
Thank you, Matt. Continuing how talking about spark detection. So, well, normally already talk about Matt's already talked about our solutions for filters and silos. And normally what you will have in a filter or a silo without protection is that you will have an ignition source, and this ignition source will come into the filter or silo and create a fire. What we have done with our systems is that we have created our spark detection system, which will identify that dangerous particle and extinguish it before it could create the fire or the dust explosion. But this creates a second question, which is which particles needs to be detected. So which are the particles that are dangerous? Well, the particles that are dangerous is that one that has enough temperature and enough energy. This means that both of them are above their minimum ignition temperature and above their minimum ignition energy. They need to have both components. If they don't have both components, then these are not dangerous particles. That means that you could have, for example, a spark that could be over 1,000 degrees Celsius, over 1,000 degrees Celsius, and but then the energy that it has or the mass that it has it's very small, so that will not create a fire. On the contrary, you could have a bolt like the one here in the image that could have a low temperature, let's say 200, 300 degrees, but then the energy is very high, and then this will create, of course, a fire. So talking about cellulose, for example, we know that cellulose has a minimum ignition temperature in a cloud. That means when it's, for example, in a filter of 480 degrees. But if we have the cellulose also, but now in a silo, which is in layer, then the temperature goes down to 270 degrees. And this is because particles are in contact with each other. So then the energy and temperature needed to create that fire, of course, is less. And then, of course, you need 0.08 joules. So what our detectors are constantly doing inside them is that they are checking all the particles that are coming in front of them, checking that they will not pass these conditions: minimum ignition temperature, whether it's a cloud or layer, or minimum ignition energy. If the detector found these two, then this will create an alarm on the process. This is so what we do and what we have, even though you could see our detectors from the outside, they look basically the same. The inside is that it changes. As I was talking, you have a minimum ignition temperature on those layers, which are temperatures that are normally lower. So we have a family that we call HD250 that will detect dangerous particles starting to 50, and then we have what we call HD400 that will, it's a detector that will identify particles starting 400. These two, as you could see, are below minimum ignition temperatures. If you compare our technology to the normal technology that it's in the market that has been there for many, many years before us, they are using a photo detector, a silicon photocell. To give you an idea, this is the same cells that are used in calculators. You know, in a calculator, you need to have light in order to work. In this case, the normal silicon photocell detector is it's designed to detect light. But as you know, and as I show you here in the table, that is not a good measure because you could have dangerous particles that are not emitting light, and that could create that fire. So it is important, and that's why we developed this technology, so you could identify these hot particles. A long time ago, we believed that spark equals fire, but that is not the case anymore, because all particles or all bodies, let's put it this way, in order to start to emit light, they need to go over the border or the frontier of 650 degrees Celsius. After that is when a body starts to shine or emit color or other emit light. So then you have all this whole spectrum of temperatures that will not be detected by a common silicon photocell detector. And of course, this technology also involves that we are not, our detectors, of course, are not sensible to daylight, as Matt showed it in the first video when one of our customers was testing the system. Extinguishing methods for our spark detection system, Matt's already talked about a little bit of this. Of course, full cone water spray nozzles and water immersion nozzles are basically the main solutions, but also we have other extinguishing methods like diverting valves, isolation valves, CO2, inner gases, argon, steam, depending on the application that we want to protect. We are not the ones saying that we do this. We went to FM approvals, and we asked them to test our detectors so they could confirm that we are detecting from 250 and 400 degrees. And actually, it took us a little bit longer than a normal certificate from FM will take, because we wanted to have these measures in our certificate. So we are basically the only company in the world that has an FM approval for spark detectors and hot particle bodies, that in the certificate is written the temperatures at which we can detect. Also, our equipment, this is a question that many times comes up, is that our systems are also ATEX approved, meaning that we could be installed in ATEX environments 2021 or 22. This is part of one of the solutions. Then the second solution is based on what we call the quick suppression system. The quick suppression systems are a complete system that it's designed for extremely quick detection and suppression of fires. As I told you, detection times of our flame detectors are normally around about 300 milliseconds. And then from that on all the way to we start extinguishing, it takes less than a second. Normally we use this to make spot protections of any types of machines or risk areas. Today we're talking about pulp and paper machines, but also we're using these same solutions to protect tissue machines or lock cells in the tissue industry, or for example, planers in the woodworking industry. Of course, these type of solutions can be combined with a Firefly spark detection system. As Matt was telling you, in the paper machines, we will have, yes, a section that could be spot protected with a quick suppression system, but also we will have, for example, a dust extraction. So that dust extraction duct will be protected by a Firefly spark detection system. Since the year 2000 that we have created this concept, we have sold and supplied more than 1,000 systems in different types of applications: paper machines, corrugators, boilers, converting machines, IR, transformers, loading and unloading areas, protection inside filters, different applications, always looking to protect the risk on specific machinery or in a specific spot of the factory. As I was commented, we have fast response flame detectors. All of these are part of our family of flame detectors. Depending on what we're using, we have a 5-channel IR detector. We have a flame detector that it's using not only IR, but also UV, which makes it very, very strong and fast. And when we just have IR, 2 IR bands detectors. Then what we use is a quick acting water mist. And why do we use water mist? We will use water mist because it will not create a thermic shock on the machine. In paper machines, regardless if it's tissue or other type of product that we are producing, normally our customers are worried about the amount of water we are using. And what we do is use water mist. As you could see in the picture, this is basically like a mist that you will have in a morning of any given day. It's not water that is thrown directly to the machinery, so it will not create that shock. Once the mist gets in contact with the high temperatures, it will expand as it changes from liquid to gaseous state. So then to the gas state. So this will create that the volume of that particle, of that drop, will grow more than 1,500 times. So this means that the oxygen then is displaced. And then this is how we put fires. It's not by the action of water itself. This is another example from a tissue machine. You could see the normal tissue environment, lot of dust around. We have our detector here. And then you will see we'll have our water mist. We have our water mist nozzles in this area, the two blue dots, sorry. And then you'll see the fire is going to start. Our detector identifies it, starts distinguishing with a water mist system. And in less than 5 seconds again, the fire has been totally controlled. The operator, he was used to fires, unfortunately. So you could see it in his body language. He's kind of surprised that it's already out. So this is what we call a quick suppression system. So once again, less than 5 seconds, and the total amount of water that we use, 6 liters. And then, of course, what it's important is that downtime, it's kept to a minimum. Factories could go back to work as soon as possible. More approvals and certificates. And this was the fire quick suppression system was fire test and approved in 2017 by DMV. And we have our certificate of compliance. This information is also public. that we are certified, and we are also approved by IMEO towards FDA and NN. Finally, before going to the question section, and if you already have some questions, please start typing them in the Q&A section. Our control system is this screen, as you could see it here in this first slide. It's a touch screen. The operator it's friendly for the operator. All is based in colors. So when everything is fine, it will be green. If we have an alarm, then it will blink yellow. If we have a detection, it will blink red. So this is to give the operator the most information possible for him, so I could make it the easiest way. Also, our system is modular and decentralized, meaning that even though there is no communication between the main unit and let's say the secondary control units on the sites that they are protecting on the of the process, these auxiliary control units will take over, and they will keep and maintain the process safe. It has a backup battery that will last you between 4 and 6 hours. Also, a very characteristic of this system, of this examining system, is that we have the possibility to connect via remotely. This in these times of COVID-19, this has been proved a really good tool for us, because we have been able to connect our customers and provide them with real-time support. Via this connection could be done via Ethernet or via 4G modem, and then you need to install a SIM card in back of the Eximio unit, and then we could connect through our different support centers here in Sweden, Spain, Portugal, depending on the region where we are. The control system also shows you each of the detections that the detector has had. It has a log. It will give you this information. It could store more than 2 million records on it. And then what you could see also is the status of temperature, humidity. Also in the applications, for example, when we are monitoring bearings, well, we could give you a trend, so the operator knows what's the trends going on, and then we could have multiple alarm levels, meaning that we could have a pre-alarm, so then the operator knows that something is going on, so he could have time to check, and we could have alarm, which in this case is the red line here. If the detector comes to these levels, then the system will activate automatically. And with this, we pass to the final section, which is other modes of detection. As we were talking before, we have the temperature sensors for early warning, that we could be surface mounted in fans, motors, or bearings, or in places and containers like silos or fiber bins or filters. And this will give you a trend, so the operator knows if something is coming. We have this application and the outlet of, as we told you, in the outlet of fans. And then the last but not least is what I was telling you, the MGD, this is the electronic nose. This electronic nose, basically, it's designed to give you an early warning of any starting combustion. So the detector is able to identify different types of gases like CO, CO2, NOxes, aromatics. So it will identify a gas pattern, and it will tell you with many hours in anticipation that there is something going on in that volume that you are monitoring. So this detector, we designed it to be installed, for example, inside silos, inside of grain silos. As you know, this is a very dusty environment. And since we designed this system and we install it, we not only install it inside grain silos, but also in warehouse areas, in biomass applications, also in, for example, in alternative fuels solutions. Well, different solutions where there is you're storing a material that could ignite for any given reason. So with this, we finished the presentation. We thank you for all your attention. Please send your questions to the Q&A section. I will leave this last image here. These are Matt's and my contact information in case you want to write us afterwards this seminar. Of course, we will send it. We will distribute it to everybody. I think we have already a couple of questions. Yes. Let's see the first one. Do you have any detector for wood yards or biomass yards? Yes, we have. Maybe let's do this. Maybe you could also activate your video, and then we could ask. Then they could see both. Yes. Yes. What we have done, Joao, for wood yards and biomass yards, is that we have open area detectors, and depending on the size of the biomass yard, we will create a matrix of detection, meaning that depending on the family of detectors, we have some of them that could identify fires as far as 30, 40 meters. Of course, it depends of the size of the flame. You know, the detectors at the end of the day work like our eyes. If you are close enough, then the flame could be really small, but as far as you go, then the flame needs to be bigger in order to be identified. So that's why normally when we have a layout, we sit with our customers and we decide what's the best relationship between number of detectors and distances. So yes, we have done that in the past. You have another one, right?
Yeah, maybe. Okay. Maybe it's. Yeah, no, it's if it's.
Yes, approvals. Yes.
If our systems and products are approved in Portugal as well.
Yes, well, our systems are FM approved, and what we have done in Portugal in all the industries that we've been working in, of course, they are fulfilled with all the European standards. Let's not confuse two things, and is that our solutions not only, let's say, in the conveyor or machine protections and machine solutions are directly to a machine and are not stated to a building, for example. So this is a common questions that we cross basically in all countries, because normally each country has its own certification, let's say, for buildings, and what the systems that we do and we create are directly designed for machinery or for a process itself. So then certifications runs in types of FM approvals, for example, or European standards that we have both ATEX standard as we have. All installations in Portugal, we have over 50 customers in different industries, going from tissue to recycling, woodworking, food. So yes, and all of these has, every time that we have installed a system, it has been, let's say, approved by local authorities when they do their checks, and of course the insurance company.
On the chat section.
In the chat section, let's see. Let's see. You can send me there. Yes. How high environment temperature affects sensors? Yes, well, normally it's at the end of the day, our detector has electronics in the inside. What it needs to be, depending on the family of detector we are using, some of them could go all the way to 60 degrees and then without any type of cooling air. Of course, our system will send an alarm to the control unit, and then and then it will say, well, the detector, the electronics in a detector is getting too hot. Take care of that. For ranges that are operation ranges that we also have above 60 degrees, what we need is then normal instrumentation air. It's air, as we sometimes joke with some of the customers, they are not cool with oil. So it's just normal instrumentation air without any type of oil or water. And then with this type of cooling, then our detectors could work in environments easily 200 degrees. We have applications where they are in the outside of ovens, or in the also in the tire industry, where they have these ovens that are really, really hot, and so we are using them at this temperature. But again, the detector, if something is going on outside of that temperature range, it will tell you.
Yeah, we can state once again that our detectors is not affected by ambient light from the surrounding environment.
Yeah.
So
yeah, this is also coming into on this question is basically our detectors are infrared, so they will not be affected by normal daylight. Of course, if you put a detector and you point it to the sun, of course it will detect, because the sun is the biggest, let's see, the biggest generator of RR radiation in our universe, or our part of the universe. So of course, this is sometimes a question that some of the questions ask us, because of course, if you're pointing to the source of IR, of course it will detect, but normal daylight, it will not create. If you have a duct, when you have a small opening and daylight is coming in, our detector will not register that as a false alarm. Yes, another question regarding the conveyor. They are asking me about the amount of water that we use. On the conveyor, we are normally using water mist nozzles instead of deluge nozzles. Why do we do this? Because our feedback from several of our customers, particularly in the pulp paper industry and biomass industry, is that normally when you have a conveyor that has some type of a degree of inclination, then what is not destroyed by the fire ends up destroying by the large amount of water that it's being used, because then all the water goes down, and then it creates a big problem how to handle all that water that it's coming down that conveyor. So instead of controlling the fire, yes, it will control the fire, the leach water, but then it will create a secondary problem. What we have done with our conveyor guard solution is that we are able actually to activate by zones. That means that in large conveyors, let's say 300 for 400 meters long, we will be able to create zones, meaning that we could detect and activate the system by zones of conveyors, not necessarily the whole conveyor, but we could also activate in zones that are alternating between in the length of the entire conveyor. I don't know if there is any other question. If you want to add your questions in Portuguese, please feel free to do that.
I can. One question I get sometimes is we talked about approvals and certifications. What type of fuel our systems is actually approved against, and we've been talking about both wood chips, and we also talked about hydraulic and lubrication oil, and our systems is approved for solids as wood chips, and as well Class B diesel. And the ignition temperature for diesel is well, about 62 degrees Celsius, and for lubrication oil it's about 200. So therefore our systems is also approved for oils such as lubrication and hydraulic oil, since diesel is more dangerous, more prone to ignite. Yeah, that's.
Well, I think that's the question. Now we have another one. what about the maintenance of the detectors? Yeah, the maintenance of detectors, it's very easy to do. Basically, if we're talking about, for example, the spark detector, this spark detector is holding, it's a welding ring that has basically two screws, two bolts on each side. So basically you just have to unscrew it, take out the detector, you have a wet towel, and with that you will clean the detector, you put it inside it. For the nozzles, you don't have to throw water into the process. You have a pin, you take out that pin from the nozzles, and then you could test the system and test the water system outside of the process dock. For the open area detectors, basically is the same procedure. In the case of open area detectors, they have a built-in function that it has 5 levels of regulation, meaning that as the detector gets dirty, it will regulate to level number 1, 2, adjust to level 1, 2, 3, 4, 5. When it gets to level 5, then it will send an alarm to the alarm panel and tell the operator, come on, don't forget about me, come and clean me up. And then this is also the same procedure. You have a wet towel, you clean the detector, and that's about it. Normally, when we install a new system, we tell the factory that test the system, run the systems, check them after 2-3 weeks just to see how dirty they are, and from then they could create their own maintenance procedure for different zones and different detectors. Nevertheless, you'll have you have the alarm in the control panel that the detector is dirty. Well, this is part of the process. Yes, in Portugal, we have a network of we have an agent in the Porto area, and then we service. Well, basically, I will talk about the whole peninsula, Spain and Portugal together. We have an agent on both sides, one in Portugal, one in Spain, and then we also have 2 office centers, one in Spain and one in Portugal. And since the countries are very close together, then we use, let's say, we use the same base for servicing the both countries. And this has been, again, very helpful in these COVID-19 times, because even though there have been closures, partially closures or total closures of countries, we have been able to work and service our customers throughout these months. So I don't know if there is any other questions. We still have a couple of minutes if you want. If not, here you have it, our emails, either Mats or myself. Please feel free to send us any comment, question. We'll be glad to answer it. And of course, we will also be distributing this webinar presentation by a link and also by Tecnicelpa's site. So I think that with that, we say, yeah, we hand it over to Ms. Dulce. If you want to make a final comment.
I just want to thank you so much. It was a wonderful presentation. I think it is very important, this subject, this matter about fire and protection from fire. And usually it's really a big problem in our kind of industry. So we appreciate your cooperation, and we'll be here for some other sessions if it's necessary. Thank you so much.
Yes, thank you to you too, everybody who took the time to hear us, and please feel free to write us. Thank you very much, and keep safe, and have a very good afternoon.
Thank you. Bye.
Bye-bye.